Hey guys, it's Miss Johnson back again to give you our second video of Unit 1. Thanks for tuning in today, and go ahead and take out your notes sheet and follow along. Today we're talking about percents, like percent of change and finding percent, and also absolute value. So up at the top, just a little review for us. To find a percent given a fraction, we divide the numerator by the denominator. Divide the numerator by the denominator. And then also remember that we have to move the decimal point 2 places. To account for that percent being out of 100. Just a quick review. If you received 21 out of 24 on your last quiz, what percentage of the questions did you answer correctly? Well, we take 21 divided by 24, which is literally what the fraction bar actually means. This means division. So 21 divided by 24 in your calculator should give you something that looks like 0.875. I take my decimal point, move it 2 places to the right. That's equal to 87.5. Don't forget that percent sign. Once you make it a percent, the percent sign's there. Once you take it out of a percent, then the percent sign is gone. So to find a percent given a decimal, just simply move the decimal point 2 places to the right. So that's the same thing as saying that it's multiplied by 100 to make it to change to a percent. So express 0.0235 as a percent. Take that decimal point, go 2 places to the right. That's 2.35% there. When we use proportions to find percents, we have something that looks like is and of equals percent out of 100. Is the part, that's the part of your question, and of is the whole, or the total. Okay, so it's always part out of total or part out of whole, and that's what the is and the of tell you. So when I'm setting up that proportion, I have what percent of 45, what percent is 45 of 78? So is my part, that means 45 is my part. Of is my whole, so that's 78 is my whole. And the what percent is the question, which means that's like my variable. Percent's always out of 100. And then when we solve proportions, just to review, we cross multiply and divide. So when I cross multiply and divide that, I get about 57.7%. In the next one, what percent of 45 is 115? So now, remember that is the part, of is my whole. So 115 is my part, of is my whole. That's some serious extra credit going on right there. So 115 is my part, 45 is the whole. I have percent out of 100, or x out of 100, either way. When I cross multiply and divide there, I get 200. You're going to get approximately 2.556, but remember we got to move that decimal point 2 places. So that ends up being 255.6% approximately. Why don't you guys go ahead and see if you can pause the video at this time and figure out number 3. 12 is 15% of what number? So now you know the percent, you're trying to figure out the missing number. So you guys see if you can figure out that one. Let's go to percent of change. The percent of change is something that's increasing or decreasing, represented as a percent. So we need to look for the difference in the amounts, or the change in amounts, and divide that by the original amount. That's how we find percent of change there. So in the first question, the number of students at Franklin High School increased from 840 to 910 over a 5-year period. What was the percent of increase? So I'm going to find the amount of increase first. That means I need to take the new amount, 910, and subtract the old amount, 840, and I'm going to divide that by the original, the old amount, 840. So when I do that, 910 minus 840 gives me 70. So 70 divided by 840. When I do that, I get 0.083 repeating. So then turning that into a percent, that's going to be, move that 2 places, about 8.3 repeating percent. Okay. In number 2, it says a TV was originally $400 but is now $345. What is the percent of decrease in the TV? So now I am looking at an original dollar amount of $400 and is now $345. So I'm going to take the 400, subtract the 345 because that's my change in amounts. But this time my original one was the bigger one because it started higher and it's going down. So it's divided by 400. 400 minus 345 gives me 55. 55 out of 400 ends up giving me approximately 0.1375, which is 13.75%. And there you have it. Let's flip it over to the back. Find the total price of each item. So this is now where we have a discount that we have to apply, then we have to take the tax, and then we have to figure out the total price. So the first thing, I'm going to, for my umbrella, I have a 20% discount. So I first need to figure out what 20% of $14 is. Another way that you could do that is figure out what you're paying. If it's discounted 80 or 20%, then that means you're paying 80%. So I'm just going to go ahead and figure out what 80% of 14 is. So 80 out of 100 equals x out of 14, because 14 is my total. When I cross multiply and divide, that gives me $11.20. And you can do that on your calculator, 80 times 14 divided by 100. So now I'm at $11.14, but then I need to figure out the tax as well. So I need to add 6%. Again, a couple of ways you can do that. You can figure out what 6% of 1120 is and then add it back on. Or you can take the 1120 and multiply it by that plus the tax. You know that you're going to have 100% of the price. That's like saying 1. But you're also going to have a 6% tax, so that's 0.06. So I'm going to take the 1120 and multiply by 1.06. That gives me $11.87. That is my final price. Why don't you go ahead and stop the video at this time and do part B on your own, and then we'll come back together and just talk about that absolute value box for a second. So moving on to the absolute value box. Absolute value is of a number is its distance away from 0 on a number line. Distance away from 0. So one thing that we need to consider is, since this is a distance, okay, absolute value is distance, there is no such thing as having a negative distance. Distance is always positive. Even when you're walking backwards or in reverse in your car and driving backwards, you're still moving a distance. It's a positive distance. There's no such thing as negative distance. So I'm talking about the distance away from 0 on a number line. I'm always going to have a positive value. Most of us are familiar with the absolute value bars. These guys right here. The two straight up and down bars, a lot of people confuse them with parentheses. They're actually bars. Most people are familiar with that. So for example, if I'm taking the absolute value of 7, that means I want to ask myself, how far is 7 from 0 on a number line? Well, it's 7 units. So I get an answer of 7. If I take the absolute value of -7, how far is -7 from 0 on a number line? Still 7 units. So again, there's that positive thing. Distance is always positive. So then it says, when solving expressions, the absolute value bars act as parentheses. Perform any operations on the inside of the bars first. So I'm going to take a look at my 2 examples there, and I want to evaluate 1.4 plus the absolute value of 5 times -3 minus 7. So I'm going to work inside those bars first because they act as parentheses. So I have 5 times -3, that's -15 minus 7. And then -15 minus 7 gives me -22. So I have 1.4 plus that, 1.4 plus the absolute value of negative 22. Find the absolute value now. The actual absolute value of negative 22 is positive 22. So you have 1.4 plus 22. My absolute value bars are gone now because I've actually figured out what the absolute value is. So I take those two and I add them together and I get 23.4. Why don't you guys go ahead and pause the video right now and see if you can work on the last example in that box. So this example right here. And that's going to take us to the end of our video for today. Thanks for watching, and we'll go ahead and come back together tomorrow.